Hello, environmental chemistry, and welcome back to the 12 o'clock Monday, Wednesday, Friday news. In today's story, we're going to be looking at a group of college students. We're going to see how they learned about pharmaceutical pollution. And we're also going to be hearing from one of our experts on pharmaceutical pollution, how it affects our environment, and what you can do to prevent pharmaceutical pollution. Let's get into today's story.
What the heck?
Would you drink this water?
Looks clean, right? But what if I told you guys it's filled with antibiotics, painkillers, and even antidepressants?
So, pharmaceuticals on our water? That's pretty nasty stuff. Let's hear a message from our boy Phil. Take it away, Phil.
Pharmaceutical pollution refers to the contamination of the environment, particularly water bodies, soil, and even air, by pharmaceutical substances, including active pharmaceutical ingredients, metabolites, and other chemical residues from drugs. This pollution primarily originates from several key sources. One major source is the improper disposal of unused or expired medications by individuals, often through flushing them down the toilet or throwing them in the trash. Another significant contributor is pharmaceutical manufacturing facilities, which can release drug residues into wastewater systems during production. Additionally, hospitals, healthcare facilities, and veterinary clinics contribute to pharmaceutical pollution by disposing of medical waste containing drug residues. Finally, agricultural activities, particularly livestock farming, also play a role, as antibiotics, hormones, and other drugs administered to animals can enter the environment through manure and runoff.
Pharmaceutical pollution occurs when medications, such as antibiotics, painkillers, antidepressants, and hormones enter the environment through wastewater, improper disposal, or pharmaceutical manufacturing waste. Once in water bodies, these substances can have harmful effects on aquatic ecosystems. For instance, hormones from birth control pills have been linked to reproductive abnormalities in fish, including feminization of male fish, which disrupts population balance. Antibiotics in the environment contribute to the rise of antibiotic-resistant bacteria, making infections more difficult to treat in both humans and animals. Beyond water pollution, pharmaceutical residues can accumulate in soil, potentially affecting crops and entering the food chain. Over time, these pollutants may also seep into drinking water supplies, posing risks to human health.
So if you want to help, here's what you can do.
Make sure to dispose of your medicine properly and check for take-back programs.
Never flush your medicine or pour it down the drain.
And remember to spread awareness. Tell friends and family how small action can make a big difference.
So, would you still drink this water?
As long as we all do our parts, I'd say cheers.
Yay!
Presents.
Ready?
We rollin'.
As long as we all... Okay.
A big difference. By the way, it's sitting.
Oh, y'all are still here. This concludes today's broadcast. We'll see you again next time. Thanks.
If you haven't heard about PFASs, you need to watch this video. What are these chemicals? Do they really cause cancer? And how did they become the subject of the recent Hollywood blockbuster, Dark Waters? Here's the crucial science you didn't see in the film. PFASs, or perfluoroalkyl and polyfluoroalkyl substances, are a group of man-made chemicals originally used for coating tanks, but are now used in waterproof clothes, firefighting foams, Teflon pans, and even pizza boxes. PFASs consist of a carbon chain surrounded by several fluorine atoms joined to an acid group. The carbon-fluorine bond is incredibly strong and causes the carbon chain to repel water and oil, as well as shielding it from just about any biological, chemical, or thermal attack, below 1000 degrees C. These incredible chemical properties allowed PFASs to be used in thousands of different products, but also allowed them to become almost untreatable toxic pollutants. Keep watching to discover the history and future of these chemicals, as well as 5 easy tips to fight PFAS pollution. Carbon-fluorine bonds are rarely found in nature, and so no life or other natural pathways have evolved to break them down. PFASs also bioaccumulate, meaning that once they get into living tissue, they remain there, building up progressively higher concentrations, which also increase along the food chain. To make things worse, these compounds are unaffected by conventional water treatment systems, and as of 2016, at least 7 million Americans' water supplies are tainted with PFASs. And scientists have actually found PFASs in water samples almost everywhere on Earth, as well as in soils, plants, animals, and in 99% of humans. Technologies have been developed to remove PFASs from water and soil, and are slowly being implemented. But the challenge remains as to what to do with these nearly indestructible chemicals once collected. This is something academics and industrial groups are still working on. But just how toxic are they? PFASs cause increased risk of hormone imbalances, high cholesterol, reduced birth weights, testicular, prostate, pancreatic and liver cancers, possible DNA damage, and birth defects, to name a few. Many of these symptoms were discovered by 2 of the companies who made PFASs, DuPont and 3M, in their own workers. But almost none of this was ever disclosed to its customers, employees, the EPA, or the communities it was poisoning. Despite the dangers and having alternative disposal methods for decades, DuPont released hundreds of tons of toxic PFAS into the Ohio River and contaminated the water supplies of over 100,000 people in West Virginia, making many of them extremely sick. This is in addition to the thousands of tons of PFASs in Teflon products, which ended up in consumers' homes and food and eventually landfills around the world. DuPont even developed a less toxic and less bioaccumulative alternative to use in its manufacture of Teflon, but decided against it as the profitability of the new chemical was unknown. By the early 2000s, the average American had 5 times the amount of PFAS in their blood that DuPont considers safe for its factory's drinking water. Thankfully, 3M ceased the manufacture of some PFASs in early 2000, with DuPont following suit much later in 2013. A lawsuit headed by Rob Bilott, the real-life hero on which the movie Dark Waters is based, eventually proved DuPont's guilt over the illegal dumping of PFASs. As a result, they agreed to implement water filtration systems in the affected areas, which they failed to do. The lawsuit did, however, fund 7 years of scientific study into the health effects of PFASs, including the largest epidemiological study in human history, with 71,000 affected civilians as participants. Researchers proved a link between one PFAS and increased risk of kidney cancer, testicular cancer, thyroid disease, high cholesterol, preeclampsia, and ulcerative colitis. DuPont disputed the findings, but eventually settled for around $700 million. However, DuPont makes over $1 billion a year from Teflon alone, and has never admitted any guilt. In the last decade, 2 PFASs, PFOS and PFOA, were added to the Stockholm Convention, which strongly regulates organic pollutants. These 2 chemicals are now only permitted for use in small quantities where no alternatives exist, such as in scientific research. However, at least 5,000 new PFASs have been developed, which are much less regulated or medically understood. Some of these new PFASs are less harmful and less bioaccumulative, but can be converted into more harmful products once they've partially degraded in the environment. Drinking water standards now limit PFASs to a few parts per trillion. That's equivalent to about 1 drop in several thousand Olympic swimming pools, but no one is really sure of a safe limit, other than none. The actions of Rob Bilott go to show what a truly monumental difference one individual can make. That said, here's 5 easy tips you can take to fight PFAS pollution. 1. Support action to regulate these chemicals in consumer products by going to www.darkwatersfilm.co.uk/sign-up and sign the petition. 2. Be informed about what's in the products you buy, including in packaging, and avoid PFASs wherever possible. 3. Consider buying a ceramic or steel pan next time you need new cookware to reduce the amount of PFASs in your food. 4. Petition for governments and water boards to measure the concentration of PFASs in household water supplies. 5. Understand more about the history of PFAS pollution by watching the film Dark Waters, and also read the New York Times article The Lawyer Who Became DuPont's Worst Nightmare, on which the film was based.
Welcome everyone, I'm Will.
And my name is Rabia Khatun Munia.
And today we're going to be talking about ethanol. Ethanol has been produced for thousands of years for consumption and sanitation.
and it was discovered in 1796 by Johann Tobias Lewis by passing it through charcoal filter.
There are different ways of producing it today, and today we'll be learning about those different ways and if we can produce it at home from our local organic chemist, Mostafa. With Mostafa,
Hi everyone.
and he'll be talking to us today about ethanol. So thank you for being here.
Thank you, Will.
And just to start off, what is ethanol?
Ethanol is a simple organic structure. It is C2H5OH. This is an alcohol group. It is called an hydroxyl group. It is CH3CH2OH.
Wow. Very simple structure.
Yeah, it is a simple structure.
So how is it made?
Actually, it's made using a fermentation process using yeast. We can use a different sugar like glucose. It will produce an alcohol and carbon dioxide.
Okay, so all the different kinds of sugars can be used to ferment?
Yeah, there are a different feedstock can be used, and this is a simple equation. It actually used in industry to produce ethanol. It's used in a larger scale to produce this very important product, which is ethanol.
Wow, so many different things can be used to make ethanol.
Yeah, many different things. And today we are gonna to show you how we can make ethanol using a simple sugar, table sugar at home, which is sucrose. Today in lab we will show you how to make it.
Okay, and once we make the ethanol, is that it, or is there any other additional steps?
No, we need to make distillation to it to make it more, more concentrated. Because after it produced in around 12 or 20% of ethanol and a lot of water. So we need to remove this water and preserve this ethanol.
Okay, so we just need to further concentrate the ethanol in order to use it.
Yeah.
So what are some of the uses that people use ethanol for?
Actually, ethanol has been used for a long time and from for back civilizations. You know, ethanol has been used in sanitization, and it's been used in the fuel system. It's actually a very benefit product in the fuel system where it has a higher octane number, and it's prevent or make it lower carbon dioxide and carbon monoxide into the environment after combustion in the engines.
Okay, so we can add ethanol and it'll raise have a higher octane rating, and it'll be less carbon monoxide.
Yeah, that's true.
Okay, so that seems like something we would want to put in the fuels.
Yeah.
Okay, so is there any way we can go to the lab and show this process?
Yeah, we will go to the lab now to show how we can make it.
Hello, now we're in the lab with Mostafa. So what's the setup that we have here?
We have here the setup for the producing of ethanol at home. If you wanna to make it, we just have a sugar dissolved in water and then have the yeast. And this is the closed system we used. Why we use this closed system? We use it before yeast are working in anaerobic system, which is mean work in no oxygen atmosphere. So I'm gonna to show you now how you can make it. So firstly, we will add the sugar. And then we will add to it the yeast. And then we need to keep it. If you can see here, this is a byproduct which is carbon dioxide.
Wow. That's a really cool setup. So you guys just bubbles out and it keeps anaerobic conditions.
Yeah, this is to keep it.
Thank you, Mustafa, for this valuable information.
Yes, we learned a ton about ethanol, like its structure, how it can be produced, and its many uses.
And thank you all for watching this video. Thanks.
trying.
As the search for alternative energy sources remains a priority, nuclear power is a powerful alternative that does not release carbon emissions. It is currently providing 10 to 15% of the world's electricity. But there's a challenge we must address: nuclear waste. Every year, nuclear reactors produce thousands of tons of fuel waste, material that remains radioactive for thousands of years. Managing this waste is a critical concern for our environment and future generations. The United States currently stores over 90,000 metric tons of this waste. But what if we told you that over 90% of this waste is still usable? Nuclear energy is generated through a process called fission, where heavy atomic nucleus, like uranium or plutonium, split into two smaller fragments of roughly equal mass to release energy. Neutrons that are emitted during this process can induce fission in other nearby nuclei, causing a chain reaction. This chain reaction is vital for nuclear reactors by creating a continuous cycle of fission. The nuclear fuel used to feed these reactors is typically used for around 5 years before being discarded as waste. But this waste can be recycled using reprocessing techniques. Once used, the spent fuel rods are stored in liquid pools of water or dry casks for cooling to allow the radioactiveness of the waste to decrease. One of the widely used methods for reprocessing waste is the plutonium-uranium recovery by extraction, or PUREX method, which can separate uranium and plutonium from fission products. Mostly composed of uranium dioxide, the spent fuel is chopped into small pieces and dissolved in nitric acid to create a solution of uranium, plutonium, and fission products. This acidic solution is mixed with an organic solvent that the uranium and plutonium nitrates can bind to, separating the usable material from the remaining aqueous solution. To separate the plutonium from uranium, a reducing agent is added to the organic mixture to cause plutonium to become less soluble in the organic phase, transferring it back into an aqueous phase. Through a purification process, the remaining uranium is stripped from the organic solvent using diluted nitric acid and can finally be converted back into usable as reactor fuel. The aqueous solution is treated to precipitate plutonium oxide. The final fission product containing aqueous solution is highly radioactive, and countries like France concentrate and embed this waste in glass for long-term storage and disposal. The plutonium oxide byproduct of nuclear waste can be used to create MOX, or mixed oxide fuel, which is composed of a mix of natural uranium oxide, reprocessed or depleted uranium, and plutonium oxide. Reprocessed and depleted uranium is a subproduct of the natural uranium enrichment stage in the fabrication of conventional fuel. Because of this, MOX fuel is the best way to recycle nuclear waste, because using reprocessed uranium will conserve the natural uranium resources, as well as reducing the waste produced in the nuclear industry. Since 1972, 44 reactors all over the world have used MOX fuel, but more research in lowering the cost of MOX fuel will be needed to expand its usage in more reactors. Nuclear energy has recently seen bipartisan support from the United States government. Results from this support include the establishment of the National Reactor Innovation Center in 2017 and the construction that has begun on Units 3 and 4 of the Plant Vogtle nuclear site in Georgia, the first new nuclear project in the United States in 30 years. With the start of Donald Trump's recent presidency, however, some nuclear research programs, including those funded by the Department of Energy, could face cuts or delays. Trump's nominee for Energy Secretary, Chris Wright, has commented that we need to build American nuclear infrastructure on mining, on enrichment, on power production, and on waste disposal, which is a tough challenge, implying that the future of the domestic nuclear industry is not dim. Trump's recent executive order, Unleashing American Energy, has the potential to cut and expedite regulatory processes for the energy sector. Though clearly intended to benefit fossil fuel industries, these changes may also make nuclear energy projects easier to execute. In light of this, many companies have been making moves in the nuclear sector. Oklo Inc., a Silicon Valley startup, has made a deal with the Idaho National Laboratory to recycle used nuclear fuel in its new Aurora microreactors. Oklo has also agreed to supply nuclear power to 2 data centers with 750 megawatts of electricity. Abroad, the nuclear industry is moving towards a more sustainable future as well. France's Unit 2 at the Cruismice nuclear power plant started with an entire core of recycled fuel for the first time. Despite the unease created by the political tension around the world, The nuclear recycling industry is poised to make great strides in the future, and the outlook is bright.
This is Big Teflon.
We're going to cover environmental and societal impacts of PFAS. I'm Brady Gill, and I'm going to cover what exactly PFAS is.
My name's Grant, and I'm going to cover where PFAS are in the world.
My name is Rhett, and I'll be covering the environmental impacts. My name's Walker, and I'll be covering the health concerns and the environmental releases.
What is up, Big Teflon Nation? I'm Brady. Today we're going to talk about PFAS, otherwise known as forever chemicals, also known as polyfluoroalkyl substances. These polyfluoroalkyl substances are man-made compounds with incredibly strong carbon-fluorine bonds that make them resistant to breaking down. That's why you'll find them in everyday items like non-stick pans, firefighting foams, and even waterproof fabrics. The same durability that makes them so useful also means that once they're out in the environment, they stick around for a long time. So let's dive into this issue a bit more. Now I'd like to pass things over to Grant, who will explain what exactly this means for our environment when these polyfluoroalkyl substances get out there and get loose.
Thanks, Brady. Hi, everyone. I'm Grant, and we're going to talk about the PFAS circle that never ends. It starts with the release into the environment, and then once released, it travels through air, water, and even rain. Over time, now they build up in soil, water bodies, and even in wildlife. The process of accumulating this PFAS happens in living organisms through bioaccumulation, which means that as you go up the food chain, the level of PFAS increased dramatically. And this is a never-ending cycle, and it's why PFAS contamination is such a hard challenge to manage. Now I hand things over to Walker. He'll talk about how it affects our health and our communities.
Hello, everyone. I'm Walker. When it comes to our health, PFAS are linked to some serious concerns. Research shows that exposure can lead to higher cholesterol levels and an increased risk of cancer. These chemicals can also weaken our immune system and have been connected to development issues in children. On top of that, there are worries about fertility and hormonal disruptions. For communities that rely on local water sources, the impact can be especially severe. In short, PFAS don't just affect the environment, they have real and lasting effects on our health and quality of life. Finally, let me pass it over to Rhett, who will look at the bigger picture, where PFAS are found around the world in some case studies that show just how widespread this issue is.
Hi, everybody. I'm Rhett. PFAS contamination isn't confined to one spot. It's a global problem. For example, in North Carolina, just a few states away, an industrial discharge has polluted the Cape Fear River, impacting millions of people. Military sites across the country have also reported groundwater PFAS levels that far exceed safety limits. And in Hoosick Falls, New York, contamination has led to higher rates of cancer in the local community, which is pretty bad. This affects hundreds of households every year. Global contamination can be exemplified in this graphic. This affects not only our environment, but also our health and everyday lives. While there are ongoing efforts to regulate these chemicals and clean up contaminated sites, there's still a long way to go.
From 1947 until 1952, the Hooker Chemical Company used the Love Canal section of Niagara Falls as a dumping site for toxic waste.
President Carter declared a state of emergency today in the Love Canal area of New York's Niagara Falls, where toxic chemicals were discovered oozing from the ground.
That discovery in a Niagara Falls neighborhood triggered an environmental battle that played out on national television and became one of the most iconic in U.S. history.
In the late 1970s, an elementary school faced a buried problem, literally. A failed canal project near the Niagara River was sold to Hooker Chemical Company, which used it as a dumping ground for chemical waste. Instead of properly disposing of their hazardous materials, they buried them, a strategy reminiscent of sweeping dirt under the rug. This wasn't the harmless kind of waste. These chemicals had the potential to cause serious health issues across the town. Decades later, the company sold the land to the local school board, fully disclosing its toxic past. Undeterred, they built homes and an elementary school on the site. For a while, life was uneventful until heavy rains caused the water table to rise, pushing chemicals to the surface and into basements, forming actual puddles of toxic waste. Residents began experiencing health problems like epilepsy and asthma, and alarmingly, some children were born with birth defects. In 1978, President Jimmy Carter declared a state of emergency, leading to the relocation of affected families. The cleanup and relocation effort cost around $17 million at the time and $51 million in 2021. The entire situation was a literal and figurative mess, highlighting the consequences of neglecting proper waste disposal.
In the 1940s, the Love Canal site in Niagara Falls, New York, was transformed from a serene area into a landfill for toxic waste chemicals. Once seen as a solution to manage waste, it soon evolved into an environmental nightmare. The waste buried at Love Canal was a cocktail of hazardous chemicals, including benzene, dioxins, and heavy metals. Over time, it seeped into the ground, contaminating soil, groundwater, and homes. Eventually, the chemical waste seeped into people's basements, and the metal barrels worked their way to the surface. Trees and gardens began to die. Bicycle tires and the rubber soles of children's shoes disintegrated in noxious puddles. As a result, residents experienced a slew of health issues, including birth defects, miscarriages, and rare illnesses. Whilst tragic, these occurrences were unsurprisingly given the later discovery of exactly which chemicals the residents of Love Canal were being exposed to daily. The chemical soup poisoning the locals contained benzene, toluene, chloroform, Mirex, and dioxin, just to name a few. Initial tests were conducted by the New York Department of Environmental Conservation in 1976 and followed up by the U.S. Environmental Protection Agency, or EPA, in 1977. Residents identified 248 unique chemicals and 82 chemical compounds. Eventually, resident homes were rendered uninhabitable, turning a community into a ghost town. Today, the Love Canal disaster serves as a stark reminder that environmental consequences know no bounds. It underscores the need for stringent waste management practices, rigorous regulations, and corporate accountability.
A great social response was seen by the communities affected by the Love Canal incident. One especially notable player in this movement was Lois Gibbs, who formed the Love Canal Homeowners Association. She, along with other residents, spoke out against the atrocities to local and federal governments, leading to the evacuation of over 800 families from the affected area. Gibbs went on to form the Clearinghouse for Hazardous Waste, later renamed the Center for Health, Environment, and Justice, which focuses on helping low-income communities fight environmental hazards through training and recognition. The attention received by Love Canal both launched the environmental justice movement and also spurred the creation of new federal legislation regarding hazardous waste contamination across the whole country. This legislation included the Comprehensive Environmental Response, Compensation, and Liability Act, often referred to as Superfund. This act covers both long-term responses and the short-term removal of hazardous waste contaminants. Superfund is also retroactive, so it gives power to the Environmental Protection Agency to hold current and past responsible parties liable for cleanup costs for their actions in releasing hazardous waste. Additionally, Superfund gives funding through the taxation of the chemical and petroleum industries and legal authority to the environmental protection agencies for investigations of sites. The Superfund Amendments and Reauthorization Act was also passed in 1986 and is a federal law regarding the proper handling of hazardous chemicals and established the Emergency Planning and Community Right to Know Act. This guarantees the notification of hazardous chemical release and the report of chemical use and storage within communities. Though Love Canal had a disastrous impact on the community and environment involved, it provided a legal precedent for better care of the environment regarding chemical waste.
That's all, folks.
Good evening, and welcome back to PB&J News.
I'm Ari Baumgarten, and tonight we bring you a special report on a silent but growing threat to our planet's oceans, ocean acidification. This environmental crisis is turning tides beneath the surface, yet its effects are rippling across marine ecosystems, coastal economies, and even the global climate. Joining us live from the Pacific Coast is our environmental correspondent, Blaine Sitton. Blaine, what's the situation out there?
Thanks, Ari. I'm here on the Pacific coastline where scientists are closely monitoring changes in ocean chemistry. Over the past century, carbon dioxide levels in the atmosphere have risen due to human activities, such as burning fossil fuels, industrial processes, and large-scale deforestation. While much attention is given to increasing global temperatures, few people realize that nearly 30% of this carbon dioxide is absorbed by our oceans, causing a dangerous shift in pH levels. This is what we call ocean acidification. The consequences are severe. Lower pH levels make it harder for marine organisms to build their shells and skeletons. And this disruption is already affecting fisheries and coastal communities. To explain more about the science behind this, I spoke with Dr. Payne DeLoach, a marine biologist. Here's what he had to say.
Of all the CO2 we release into the atmosphere from energy production, transportation, and other activities, about 30% is absorbed by the ocean. When carbon dioxide is dissolved into seawater, it undergoes a chemical reaction with water to form carbonic acid. Carbonic acid quickly dissociates to form bicarbonate ions and hydrogen ions, which lower the ocean's pH, making the water more acidic. One of the most alarming consequences of ocean acidification is its effect on marine life. The excess hydrogen ions react with carbonate ions that many organisms rely on to form calcium carbonate, the essential compound for shells and coral skeletons. As carbonate ions become scarcer, organisms like oysters, mussels, and corals struggle to grow and maintain their structure. In extreme cases, existing shells can even start dissolving. Coral reefs, which support roughly 25% of all marine life, are particularly vulnerable. When corals can't maintain their skeleton, reef structures begin to erode, putting countless species that depend on them at risk.
That's right, Ari. The economic consequences of ocean acidification are also significant. Coastal communities that depend on fishing and shellfish industries already see the impacts. Oyster farms along the U.S. West Coast have reported increased shell deformities and declining harvests. If this trend continues, we could see widespread job losses, food shortages, and rising seafood prices worldwide. Scientists warn that some regions, particularly in cold waters, are experiencing acidification at an even faster rate. Places like the Arctic and Antarctic, where carbon dioxide dissolves more readily in cold water, are becoming hotspots for rapid pH decline. This could have devastating effects on krill populations, a key food source for marine mammals, seabirds, and fish. Now, let's turn to our climate analyst, Jordan Gabriel, who's in Washington, D.C., to discuss possible solutions. Jordan.
Thanks, Blaine. The good news is that there are solutions to slow ocean acidification, but they require urgent action. The most effective way is reducing carbon emissions. This means transitioning to renewable energy sources, improving energy efficiency, and protecting natural carbon sinks, which absorb large amounts of CO2. Some scientists are looking at ocean-based solutions, such as increasing the alkalinity of seawater through mineral additions, restoring seagrass meadows, and expanding kelp forests. These ecosystems naturally absorb CO2, reducing the amount of CO2 absorbed by water, helping balance pH levels. On the policy front, governments worldwide are discussing stronger regulations on industrial emissions, carbon taxes, and investments in clean energy. International cooperation is key, as ocean acidification is a global issue. The United Nations and environmental organizations are pushing for more substantial commitments and climate agreements to address the impact on oceans specifically. However, scientists emphasize that immediate action is necessary. The longer we wait, the harder it will be to reverse the damage already being done. Back to you, Art.
Thank you, Jordan. It's clear that ocean acidification is not a simple environmental issue, as a deeper dive shows economic, social, and global security challenges as well. The effects on marine life, coastal economies, and food security are already being felt, and without swift action, we could face even more severe consequences in the coming decades. Scientists and policymakers agree that reducing carbon emissions is the most effective way to combat this crisis, but public awareness and engagement are also crucial. Supporting sustainable seafood choices, advocating for clean energy policies, and reducing individual carbon footprints can all contribute to the solution. That's all for tonight's special report. Stay informed, stay engaged, and always remember, our oceans will always need our help. For PB&J News, I'm Ari Baumgarten. Good night.
Is absorbed by our ocean.